after Thanksgiving break too, so you can meet. Hey, how you doing? Great. All right. Here's our new topic here today. The word partition. You guys know that we have a library here at school. I don't know if you've ever ventured in there or not. All right. Some of you, I don't know. And then you go in that quiet area at the back. What do they call those, cubicles? Whatever, right? I don't know. Somebody earlier on this week told me they were called study cubbies. I'm not saying the word cubbies anymore. That's definitely below me. But you see the sides of them there, so you have your privacy. Those are partitions. They separate things. And what we're going to do is we're going to take segments today, and we're going to cut them up into pieces. We're going to separate them, partition them into different ratios. So before we do that on a graph, I want to get you guys in the habit of recognizing when I give you a certain ratio, like remember yesterday with the median, 2-to-1, double, and then single. We're going to break it up into different ratios, and I want to make sure we're able to do that. So this first one here, I want to break this AB, segment AB, up into a ratio of 2 to 3. Okay, break it up into a ratio of 2 to 3. Now, what that means is we're going to find a point on this line segment that to the left, you have 2 congruent segments, and to the right, you have 3 congruent segments, and all of them are congruent. So if I'm going to break this up into 2 to the left and 3 to the right, how many total line segments will I have here? 5. Everyone agrees? So can you do your best ability right now to break this up into 5 equal parts? Hey, you can do points, you can do hashes. I don't care what you do. Just break it up. Break it up into 5 equal segments for me. So everyone's got it broken up into 5. Now locate the place where it breaks it up into 2 to 3 now. I'm going to draw an arrow to one of these hash marks that says that at this point, it breaks it up into 2 to the left and 3 to the right, and that would be this one right here. Everyone see what I mean now? 2 congruent pieces to the left, 3 to the right. So this point on the segment right there would be my 2 to 3 point. Partition it off into a ratio of 2 to 3. All right, 1 doesn't make you great. Let's go to the next one. Let's do 4 to 1 now. 4 to 1. Still breaking it up into how many equal parts? 5 equal parts again. Yep, go ahead. And now does everyone see the 4 to 1 point? That breaks it up into a ratio of 4 to the left, 1 to the right. Make sure we draw an arrow here. That is where we would break it up into a ratio of 4 to 1. Everyone's all right so far? All right, what about, let's go 1 to 3 for the next one. Break AB up into a ratio of 1 to 3. Now how many equal parts? Everyone 4? Everyone agree? We're okay on how we're getting this. 4 equal parts? And then where would be the 1 to 3? Would be my first one. No issues yet? All right, I'm going to be that guy now. 3 to 5. Break that up into 3 to 5. The best ability, what are you doing now? Breaking it up into how many equal parts? How many equal parts are we breaking this up into? 8 equal parts. All good? All right, last one here. Ready for this one? One to one. Nobody wants to chime in? Okay. And thank you. Thank you. Quite. That was painful. Midpoint, right? 1 to 1. Same as saying find the midpoint. Whew. Now what I want to do is, let's do this on a graph now. Let's put AB on a graph. And hey, now you're going to actually tell me what is the XY point that cuts it up into a certain ratio now. All right, this is what I need you to do for the partitions. Boom, let's graph it. -3, -4, 1, 2, 3, 1, 2, 3, 4 is A. 2, 0, B. All right, I need to know the point that breaks AB up into a ratio of 2 to 3, the actual point. Not like a little area here, the actual point. So this tells me right here, you're going to cut AB into how many equal parts, just like we did in the last page. 5 equal parts. Everyone agrees? 5 congruent parts. Remember that. I got to break it up into 5 congruent parts. And we need to do this algebraically now. We just can't eyeball and put markings like we did in the last page. So we're going to do this twice. We're first going to do it for the x coordinate. Let's find the x coordinate of our partition point. First step, can you guys find me the distance on the x-axis between A and B? So what's the length, the distance? You don't need to use distance formula. You can count or figure it out in your head. What is the distance between the x coordinates, -3 and +2? That has a distance of how far away are -3 and +2? 5? Answer, Mageddon. How far apart are the x coordinates?
Oh. 5?
I'm calling that answer Mageddon when your number comes up and that's the actual answer. Somebody's like, what's he talking about? Forget it. Just forget it. 5, right? It's a distance of 5. And you guys just told me I have to cut it up into how many equal parts? Okay, so take my distance and divide it by the number of parts I need. 5, and that tells me what? What's that 1 tell me? Every time you break it up, you got to go 1 unit on the x-axis, right? 1 unit. So let me draw a visual up here. You do not have to. Let me draw a little visual of what we would have done on the previous page. Break it up into equal parts of 5. And this would have been the 2 to 3 point right there. Everyone agrees? So every time I move, I got to go 1 unit. Am I there yet? I got to move another 1 unit. So how many times did I move? How many times did I move to get to my 2 to 3 point?
2.
Twice, right? So I'm taking that 1 and multiplying it by 2 because I have to move twice to get to my point. So I need to move 2 total units to get there. Everyone see why it's not 1 unit or 3 or 4 units? I got to move 2 total units. I don't know why. 2 total units from where? From where I started, point A. What x coordinate did I just start on? 5 again. Where do we start on the x-axis?
2.
On the x-axis, we started at point A, right?
Yeah.
And which was what x coordinate?
3.
So I started at -3 on the x-axis, and how many units do I have to move? Add 2 to the right. Where do you end up on the x-axis now? There's your x-coordinate of the partition point. There's the x-coordinate, -1. Now we got to do it all over again, but for the y's. All right, we got to cut the y-axis up into equal parts of 5. And now here's where we may see a little decimal action. All right, everyone look at the y-coordinates. How far apart are your y-coordinates? 3? 4 apart. Everyone agrees? They're 4 apart. -4 to 0, 4 apart. All right, I still got to cut that 4 up into how many equal pieces? 5, right? That's not changing. 4 over 5, that's why we have your calculator. What do we get there? 0.8, yeah. So every time you cut it up, you got to move 0.8 and 0.8 and 0.8. But how many times in this problem do I need to move 0.8? Once, twice. I always have to move twice. It all depends on what that first number in the ratio is. All good? So I got to move twice. So I'm going to go 0.8 2 times for a total of how many units? 0.8 and then another 0.8. So total, I'm going to go how many units? 3 again? 1.6 total. That's not where I end up. That's how many units I got to move. Where did you start on the y-axis? 10. Where did we start on the y-axis? -4. So from -4, I'm going to go up 1.6 and end up where on the y-axis? 5?
Hold on. 2.4. Wait, hold on. My calculator.
You had 2.4, right? You just were missing -2.4. Yep. So the point that breaks it up into a ratio of 2 to 3 should be -1, comma, -2.4. Can I guarantee that you got it right? Not 100%, but you can feel pretty confident about yourself that you got it right, and here's how. Your partition point should land where? Where should this point always land? Not here, not up here, not over here. Where should it land? On the darn line segment. All right, a partition point should always land. So if we take a look at -1, -2, about 0.4, woohoo! Yeah, we're looking pretty good. All right, it has to land on the line segment. Yeah, I know, 1 doesn't make you great. Let's go. The only thing that's going to change is the ratio I give you. The process will always stay the same. The ratio is the only thing that will change. -2, 1, 2, 3, 4, 5. 2, 1, 2, 3. How many equal pieces are we breaking this up every time into? How many equal pieces are we breaking this up into to begin with? 7?
5.
5. Good job, Karen. Good. All right, here we go. Let's start with the x-coordinate. How far away are the x's now? How far away are the x's? Bless you. 5?
4.
4 units away. Good. And I still got to break that up into 5 equal parts. Everyone, stop me if you don't know where a number is coming from. So just like last problem, right? I'm going to go 0.8 units. But look at the ratio. How many times do I have to go 0.8? 4 times, right? 4 to 1. I got to move 0.8 4 times now. Not 2 like it was in the previous ratio. So total number of units I'm going, 6. Get on that. Don't get rattled, Nate.
3.2.
3.2. That's not where we end. That's how far we have to go from what starting x coordinate? 13?
-2.
Good. -2. Go over 3.2. And we end up at 10. 1.2? Is that what it is?
Yeah.
Is it? Why am I thinking it should be an 8? Never mind. Just shut up. I'm talking to me. 1.2? All right, this is not bad. There's one little wrinkle you have to worry about, and it's coming up right now with the y coordinate. You're going from 5 to -3. Okay, 5 to -3. So you're thinking that's a distance of what? 8, right? And you're correct, but you got to pay attention. 5 to -3. Where am I going? Up or down? 5 on the y-axis to -3. See how I'm going down? Everyone, yes? 5 to -3, I'm going down. So when I do the distance here, I'm going to have to put -8, and I'll show you why when we get to the end here. Down. Now, that doesn't mean it's got a -8 length. That can't happen. That just says we're going down 8 divided by 5 still. Was -1.6. Okay, so every time I got to go down 1.6 units. Again, how many times am I going down 1.6? Still what? 4. Hey, everyone, stop. This second number in the ratio is useless to you. You always figure out how many times you have to go by the first number in the ratio. That's how many moves you make. So I got to go -1.6 4 times for a total of how many units? 5? This kid in his calculator.
-6.4.
6.4, everyone? Good. So down 6.4. Okay, now here's why I need you to recognize to put the negative sign. Right here in this step. Where'd you start on the y-axis? 7, where'd you start on the y-axis?
-8. Sorry. -2. Oh, my. +5.
You good now?
Yeah.
You sure you want to end with 5? Okay, you're fine. So I started with 5, and ready? I have to go down 6.4. I get nervous, guys. If you didn't put the -8 here, probably you're going to do what instead? Add it. And you're not going up. You got to go towards the second y coordinate. So that's why I'd like you to have down 8 if you're going down with the negative sign. And where do I end up? 6. -1.4. So the partition point should be, was there x? 1.2, -1.4. And this is why it's nice to check here. Let's see. Over 1.2, yep. Down -1.4, about right there. It's pretty good. Now, whoa. I just want to show you. If you forgot, say you forgot that, and you added instead, you get what? 11.4? 11.4? Way up here. Something went wrong. Okay, something went wrong. Do we think it's time for us to stop holding hands and you to try out the next one on your own? All right, let's go. Let's try it out. How many equal parts are you breaking it up into?
10.
10 equal parts, so divide by 10 first. Ooh, what's that? -2 to 4, 2, 4, 6. -0.2, 2.2, looking good. Any issues? We'll do one more, and then I'll let you guys roll on to your assignment, which is just changing ratios.
Would it? Why is it multiplying the 0.4 times 3 for the y coordinate?
Because you still got to go 3 units every time.
Okay.
3 times. Like if if I break my segment up into 10 here, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so 10 equal parts, right?
Mm-hmm.
So the 3 to 7 is going to be on this one right here, right?
Mm-hmm.
So if I got to move 0.4 every time, I get ready. 0.4, 0.4, 0.4.
Okay.
Okay. This second number here has nothing to do with how many. It's always the first number here that you have to move. Good. All right. It's always times that number. Good question. Anybody else? All right. You're 1-to-1 here. Anybody? What?
I have a question.
Yeah, sure.
How do you know when to add your answer from the final chord or suspense?
Depends on what direction you're going, Spence.
Okay.
Ready? Let's go x coordinates first. From -2 to 4, what direction are you going?
We're going up 6.
No. I'm on the x-axis, right? -2 to 4 on the x-axis. Aren't I going in the -2 to 4? I'm going in the positive direction. Add. From 1 to 5 on the y-axis. 1 to 5, I'm going up. Add. If I'm ever going to the left on the x or down on the y, then I got to subtract. So that's the one thing you got to pay attention to the detail with. Okay? 1-to-1. You guys are just getting after it and finding the x and the y coordinate, right? All right, that's fine. Nobody wanted to go the alternative way? 1 to 1 is the same as, we're finding the what here?
Midpoint.
Midpoint. So you could do x coordinate, y coordinate like we've been doing. Go right ahead, divide by 2, right? Or you could do what? X,
Plus
like you've been there, please. Act like you've been there.
x2 plus x1 divided by 2.
Abbott's getting this. How do you feel, guys?
Y2 plus y1 divided by 2.
Respect. Not for that hair, but for what you just told me. That's what I've noticed lately since COVID started. Like, combs are non-existent anymore. I get it, fellas. The barbershops closed during COVID, but they did reopen. They did. They're all fully reopened now. It's okay. Combs and mirrors. Those were all discontinued for males. Combs and mirrors. Now, Spence, you see here, x-axis, I'm going in the positive direction, right? But what do you notice about the y's?
I'm going down.
Yeah, so I got to subtract at the end. Okay. Okay, any issues? All right, I'm not changing anything tonight. I think actually when you start the homework, the numbers are actually nice and divisible. There shouldn't be many decimals. I think the decimal you get is like 0.5. Everything else should be whole numbers tonight. So go ahead, get after it. Get a lot, if not all of it done by the time you leave. Notice I didn't provide graph paper, so if you want to check your answer, you got to get your own slice of graph paper out. All right.